And that's what we're about to learn. So that this type of a thing is called the mathematical foundation. Like I said before, back then there was no mathematical foundation. We use mathematics as a tool to understand this phenomena. By some point, mathematics becomes its own world, and that's why they needed it. And later, they used this foundation to extend something that's incomprehensible, general relativity phenomenon and quantum mechanics phenomenon, and they, circle, and they end up using mathematicians' imagination. So before I review further topics, let me use this nice picture, nice demonstration that kind of gives you a little lesson. All right, you will have a 2 or 3 more of this type of length. It's a little lesson, and there's no cheating or fooling around going on. What I'm presenting here is absolutely true. Okay, this is called equilateral triangle. You know what that means, right? Right. It's rigid. If you think about quadrilateral, all had 4 sides, everything has equal length. Is that rigid? It's not rigid. You can think about the joint. You can kind of move around. Can you imagine, 4 sides with all length with a joint in that? It's not rigid, but triangle is rigid. Once you have, there's no other shape. That's it. Next thing I'm going to do is put this midpoint right here and there and there. Midpoint, make sense? So let's say the length here was 1 and 1 and 1. Okay, 1 unit. And then you look at this side and that side, connecting that side and that side. Make sense? And let's calculate the length of this 4-line segment all together. Does somebody have an idea? This one and that one will be the same because it's the midpoint, parallelogram, all that. You can use plane geometry to show that. This inside and here, it's actually a rhombus, so that all sides are equal. Not yet square or anything, it's a rhombus. All right, so, and this one will be equal because it's the midpoint. The plane, facts from plane geometry. So knowing that, what would you say about the sum of all this 4 segment all together? What's the answer? 2 is the answer, right? Because this is a part of that, and this one is equal to that one. So kind of take that line segment and bring it down here. Take that line segment and bring it down here. Does that make sense? So this, adding all 4 pieces, is the same as going around like this. Good? Okay. So I'm going to take another copy of that and do exactly the same thing over here. To that down triangle down there. You see this 2 equilateral triangle down there? You do exactly the same thing for that triangle. So you find a midpoint over there, midpoint there, and kind of sum it around like this. So there's 8 pieces there. You see 8 pieces? From bottom equilateral triangle, I have 4 pieces here. From this equilateral triangle, I have 4 pieces there, right? And sum of this thing is the same as going around like this. Sum of that thing is going around like that. But we already know this sum is going around like this, correct? Therefore, the sum of these 8 pieces is still 2. And before it was a 2. So we're going to do this one 2014 more times, or 10 to the 24th, whatever the maximum number or uncertainty principle in quantum mechanics allows. That there's, if you go down there and any further, there's no way to measure that. So beyond the level of what we can understand, that's what we're going to do, right? So it's dot dot dot. You continue to do that. You can't really do it, right? We can only think about it, right? This is one of the things that I was talking about. You can't really practically can do that, but we can only think about this one. Can you think about this one after you repeat this like 10 to the 24th times, right? So how is this segment, lots of segments, going to look like all together as an object down there? Would you agree that there's no way you can distinguish that from that bottom straight line? It is so tiny, there's no way you can see any difference from bottom baseline from that line, right? And there is no technology that can actually measure the jiggling things down there. Yet, what is the length of this red part? It's 2. But what was the bottom of the triangle? 1. What's the lesson? Right, you can't just rely on what you see. You really have to think seriously, really have to do mathematics. You look at the graph and conclude something, you could be way off. How off? 1 out of 2. You could be way off, right? Okay, that's the lesson. So that's why they needed this type of serious logical development to draw really good conclusion, not by just looking at, see, looks like it. That's enough for me, and they will be way off. Make sense? All right. We did before was now we're introducing the limit of a sequence.